Section 11.3, area of circles and sectors. Number 25, a jeweler makes a pair of earrings by cutting two 50-degree sectors from a silver disc. Part A, find the area of each sector. So we want arc angle or central angle over 360. So in this case, 50 over 360 times pi r squared, where our radius is 2. So if we take 50 divided by 360 times pi times 2 squared on our calculator, we get 1.7 square centimeters. Part B. If the weight of the silver disc is 2.3 grams, how many milligrams does the silver wedge for each earring weigh? So, the entire disc altogether is 2.3 grams. We want a fraction of that entire weight. The fraction that we want will be equal to 50 over 360, because that's what our central angle is. So the fraction of the total, and the total is 2.3 grams. So 50 divided by 360 times 2.3 is approximately 0.3194 grams. We want our weight in milligrams. So there are 1,000 milligrams in every gram, so if we multiply by 1,000, that would move our decimal place 3 places to the right, and we would get 319.4 milligrams. Alright, the area of each shaded region is given. Find x. So the area is 66 square centimeters. Area is equal to pi times radius squared, and the area of the sector is equal to angle over 360 times pi r squared. So our angle is 180. And really quick here, we can go ahead and simplify this. I know that simplifies to 1/2 times pi r squared, where our radius would be half of this diameter here. So pi times 1/2 x squared. And this will give us the area of half the circle. So to simplify, we get 1/2 times pi, and we want to square this, so 1/2 squared, that would be 1 squared is 1, 2 squared is 4, x squared is x squared. Simplifying this, 1 times 1, 2 times 4, and pi x squared. Okay, so if the area of the sector is 66, square centimeters, and we have this expression that the area of the sector is 1/8 pi x squared, and to solve for x, we would multiply both sides by 8. We get 528 is equal to pi x squared. So next we would divide both sides by pi. And then take the square root. So the square root of 528 divided by pi is approximately 13 centimeters. So the area of our sector is 128 square feet, and that will be equal to our central angle over 360 times the area of the circle, or pi radius squared, where our radius is x. So we want to solve for x. So the first thing that I would do is multiply both sides by the reciprocal of this fraction. And that will cancel on this side. Okay, then I would divide both sides by pi, which is the same as multiplying by 1 over pi. So we get x squared is equal to 360 times 128 divided by 152 pi. And then we would take the square root of both sides. So x is equal to the square root of 360 times 128 divided by the quantity of 152 times pi, which is approximately 9.8 feet. Number 31, the age of a living tree can be determined by multiplying the diameter of the tree by its growth factor, or rate of growth. Part A, what is the diameter of a tree with a circumference of 2.5 feet? So circumference is equal to 2 times pi times the radius, where 2 times the radius is the diameter, so we can express this as diameter times pi. So if my circumference is 2.5, I substitute that in for C, and I solve for D by dividing both sides by pi. And you get approximately 0.8 feet. Part B, if the growth factor of the tree is 4.5, what is the age of the tree? And the original directions, it says that you can determine this by multiplying the diameter of the tree by its growth factor. So the diameter times its growth factor gives us 3.6 years. Number 33, find the area of the shaded region, round to the nearest tenth. So the area of the shaded part would be the area of the circle minus the area of the white triangle. So for area of a circle, that's pi r squared. Area of a triangle is half of the base times the height. So our radius of the circle, notice that we have the diameter here, which forces this angle to be 90 degrees, and it's isosceles. So that makes each angle 45 degrees. In a 45, 45, 90, if you know the leg, multiply that by the square root of 2 to get the hypotenuse. So the square root of 2 times the square root of 2 is 2. So the hypotenuse, or the diameter of the circle, would be 10, making our radius half of that. So we also need the base and the height of our triangle. So base is 5 square root of 2. Height, perpendicular to that, is also 5 square root of 2. So now we substitute in. The area of the circle is pi times radius squared. The area of the triangle is half of the base times the height. So we get 100 pi minus 1/2. 5 times 5 is 25. The square root of 2 times the square root of 2 is 2. 2 times 1/2 is 1. So I have 100 pi minus 25. And I just realized I made an error here. I substituted in the diameter. So I want my radius squared. 5 squared, which is 25. And therefore, my area is 25 pi minus 25, which is approximately 53.5 square meters. For number 35, our total area will be equal to the area of the rectangle minus 2 times the area of one of these circles. So, because we're subtracting 2 circles away from this total area to get the remaining area. So the area of the rectangle is length times width. The area of a circle is pi r squared. So the length and width of my rectangle are 10 and 5. The radius of one circle, well, this entire distance across is 10, so half of that, or the diameter, would be 5. Therefore, the radius would be even half of that. So 10 times 5 is 50, minus 2 times 2.5 squared is 12.5. So we have 50 minus 12.5 times pi, which is approximately 10.7 square centimeters. For number 37, our total area of the shaded part would be the area of the entire circle minus, we have 3 congruent white sectors here. So I would just subtract 3 of the white sectors. So the area of the circle is pi r squared. Our radius is 2 inches. So we have 3 of these white sectors. So the area of a sector is the angle, central angle over 360, multiplied by the area of the circle. So pi r squared, pi times 2 squared. So let's simplify some of this. We would have 4 pi minus we could simplify 3 goes into 360 120 times. 2 squared is 4.